Hey guys, glad to see that you're back with me today. Hope everybody's doing good. I want to go ahead and give you notes number 6, similarity in right triangles. Okay, there's a special theorem we're going to use to do our first example. It's theorem 7.3 that states the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle. Okay, so basically this will make a little bit more sense once we see a picture. But you have a right triangle, and I'm going to draw it a little bit different. I'm going to do a short leg, a long leg, put the right angle here, and the hypotenuse this way. Okay, so remember the hypotenuse is across from the right angle. It is the longest side, but we have a short leg and a long leg. Okay, so what they're talking about is the altitude. Altitude is height. The height of this triangle to the hypotenuse side would be right down the middle here, the way it's written. Okay, so then that would make a right angle because altitudes are perpendicular to the base. Then doing that, I have one little triangle, one medium size, and then the original large triangle. So what I've created is three similar triangles. Okay, when we talk about similar triangles, they have congruent angles and proportional sides. So that's basically what I've made here. All right, let's go ahead and get some letters on this example and what they want you to do. Okay, so they want us to name the three similar triangles that we've created. Okay, and they want us to do it in a similarity statement. So I'm going to start with the original. And let's look at how I named it. X, Y, Z. That's the short leg, the long leg, then back across the hypotenuse. I need to do that in a similar fashion with the next triangle. Okay, so then here I've got a short leg, I can see, a long leg, and a hypotenuse. Short, long leg, hypotenuse. And then this one looks a little weird. It's a little bit hard to tell with the way I've got it drawn. Usually in the book, they give you examples that you can tell real easily. But it should be, this is the short, this is the long, and this one is the hypotenuse. So it should go X, W, Y. So this is a short, this is a longer leg, and this is the hypotenuse. Okay, so there's an example of three similar triangles created by an altitude to the hypotenuse side. Okay, then the next thing I want you to be able to do, the next skill, is find the geometric mean. Okay, and we'll call those numbers A and B. All right, geometric mean's not like arithmetic mean. Arithmetic mean, you would add A and B together and divide by 2. Geometric mean is different. It's actually dealt with in a proportion. So it's like this formula. X over A equals B over X of your two numbers, A and B. Okay, so there's your formula. Okay, and then we'll see what the usefulness is of geometric mean later. On ACT, they may just ask for the geometric mean to see if you know how to apply it. Okay. All right, so here's our example 1. Find the geometric mean. They have to give you 2 numbers. Okay, in this example, we'll do 6 and 12. So that would be x over 6 equals 12 over x. And you cross multiply. X times x is x squared. 6 times 12 is 72. You want to square root both sides since it's quadratic. Okay, and then let's come over here to the side and break down 72. So we can do 6 radical 2. We have twins here. We can take out of the radical. We have to leave the 2 inside. Okay, now technically we would say plus or minus 6 radical 2, but because we are doing a relationship to a geometric figure later, this will actually apply to our triangle later. We'll just do a positive answer. Okay, and then here's one more example of that. Find the geometric mean of, and they're going to pick whatever numbers. This one's 8 and 16. So x over 8 equals 16 over x. X times x. 8 times 16 is 128. Square root. Let's come over to the side and break down that radical. 128 will go 64 and 2. 64 is 8 times 8. So we have twins. The twins come out. The 2 stays in. So we have 8 radical 2. Okay, so these are the skills I want for you today to be able to use this theorem to divide it into 3 similar triangles and to cross multiply and find geometric mean, leaving it in simplest radical form as shown. Okay, so it's good to at least talk to you guys, and I'm hoping to see you soon. Have a good day. Bye.